Anne Levin uses Zephyr, an instantaneous messaging system, to broadcast a question over the Athena network of over 1,300 workstations.
During the Civil War, who gave the opening speech before Lincoln delivered the Gettysburg Address?
Immediately, the message pops up on workstation screens across the network. Those receiving the message subscribe to a channel called White Magic. It's like tuning into a Citizens Band radio channel to hear what is going on. If you're not tuned in, you miss the message. The question sparks 20 students to chat about the Civil War over the network. They decide to create a new channel called Civil War and continue their discussion. Anne can send and receive a Zephyrgram from any Athena workstation. She doesn't have to know where or even who an individual is on the network. Zephyr will instantaneously deliver the message to anyone who is subscribing from an Athena system anywhere in the network. In 1 year, users exchange millions of Zephyrgrams.
Zephyr is used also for distributed maintenance. We don't have a central operations control room because the day-to-day operations maintenance staff can communicate immediately and selectively with Zephyr anywhere on the network. For example, if a file server begins to fail, it will log the errors and also send a Zephyrgram to alert the staff. If, for any reason, we need to take a central service offline on short notice, Zephyr provides us the means to instantaneously notify all the active users of the particular service without sending a broadcast to everyone on the network.
Zephyr is also integrated into our online consulting system. This system connects users and consultants who may be located anywhere on the network and tracks the progress of all unanswered questions until they're resolved. The online consulting system makes use of Zephyr to tell users and consultants they've been connected and that new messages have been sent. Consultants use Zephyr to conference among themselves and with operations and telecommunications personnel. Our consulting staff of 9 full-time equivalent consultants plus volunteers currently answers 2,500 questions a month, a rate which far exceeds those for questions handled in person or over the telephone.
In 1983, MIT launched Project Athena, an experiment supported by the Digital Equipment Corporation and the IBM Corporation to explore the educational use of a vast network of computer workstations. Today, 10,000 students and faculty can log in at any workstation located in 40 clusters, 150 offices, and 5 living groups. Athena also reaches into 2 lecture halls and an electronic classroom. This highly distributed yet centrally managed network required a distributed system design far more advanced than any previously available. One requirement was a completely rethought and redesigned authentication system. For example, when Zephyr sends a message, it verifies that the sender is authentic, in other words, a legitimate Athena user, so the recipient can be certain the sender is who he claims to be. The authentication process for all distributed computing services begins at login, when the user's name is sent by the workstation login task to Kerberos, the authentication server.
The Kerberos server provides communication security for every host, user, and service on the network. To authenticate a user, it seals an encrypted ticket in an envelope that can only be opened by the intended recipient. That envelope is opened by the password at the workstation, and this encrypted ticket allows IDA to ask for more tickets that allow access to other network services. With this scheme, no clear text password is stored or goes over the network. The authentication process is secure and provably secure from network eavesdroppers. Even if the ticket is copied by an illegitimate user, as it crosses the network, it can't be used to gain access to protected services. Each of these tickets has a containment lifetime, which helps to protect the integrity of IDA's data. Now IDA would like to edit a report. From a text editing window, she'll call up the file that contains that report.
At login, IDA's ticket went back to Kerberos to ask for another ticket to gain access to the file server, which has stored her file.
IDA's file isn't stored locally on the workstation she's using. It's stored on one of many Athena file servers, and in fact it might be on a disk all the way across campus. But IDA doesn't have to know which file server the file is on. The Athena Hesiod service keeps track of that, along with lots of other important information associated with files, users, workstations, and other components of the Athena environment. For example, when IDA logs in, the login program on her workstation communicates with a Hesiod server to find where her personal files are stored so she can access them. Login makes IDA's remotely stored files seem attached to the local workstation. At Athena, we currently support 3 different types of file systems: NFS, or Sun's Network File System, which we've enhanced with some Kerberos security features at the server end; AFS, which is Transarc's Andrew file system; and RVD, which is the MIT-designed remote virtual disk.
The X window system allows IDA to simultaneously open windows for other applications and network services such as mail. In combination with the Unix operating system, the X window system is the vital service that allows data to be displayed uniformly, regardless of the make of workstation connected to the network.
At the heart of many educational applications of computing is the use of visualization to help understand and illuminate difficult concepts. But visualization calls for programming of a display, and historically, that display programming has presented the application designer with a hard problem. Each display is programmed differently, so you can't write one program that runs on several different manufacturers' computers. Even worse, most manufacturers have several different displays of their own, so one program often won't run on more than one product of one manufacturer. The result is that if you want to use visualization, you have to plan to rewrite the display part of your application once for every different display device on the campus. In addition, each year manufacturers announce new display devices, so you have a job that goes on and on. This need for extensive and continued commitment to display programming has really inhibited people who have good ideas they would like to try. To deal with this problem, Project Athena, together with the MIT Laboratory for Computer Science, undertook the development of a new standard programming interface for display devices, and the demonstration of this new interface on several different displays made by its 2 sponsors, IBM and Digital Equipment Corporation. The new standard display interface is called the X window system. People who write visualization applications have found that this development has been astonishingly successful in 2 ways. For the first time, a long-held dream has been realized. One can write a program in the environment of a digital workstation and expect to move that program to an IBM workstation without reprogramming. Our students see the benefit of this success every day when they do their homework using different kinds of workstations interchangeably. The second success is that the workstation manufacturing community has embraced this new standard so swiftly that virtually every engineering workstation made anywhere in the world now provides, as part of the manufacturer's operating system, the X window system standard. We're beginning to see the benefit of this second success in the form of applications written elsewhere that can be imported and used at MIT with very little effort.
When